Alright, hello. This is Integrated Math 2 lecture for September 9th. We're going to be talking about inverse trigonometric functions and also do a bit of review of the foundational trigonometric functions. So let's get started. Let me turn off the webcam. Alright. So I want to start with just a quick review of a video you guys should have watched yesterday. Just using your basic foundational trigonometric functions to find a missing side for a triangle. So this is an example problem from a problem set in Khan Academy that you might see. So we need to find the length of AC right here, so label with a question mark. And the information we're given, we have a right triangle ABC, we have an angle that's 25 degrees, and we know the length of side BC is 5. So with that information, how can we find AC? Alright, so let's go to our whiteboard and we'll do that. Oops, this is, I guess I forgot to label that. That's 5, let me just make double sure. Okay. Alright, so we can find this pretty easily using our basic trigonometric functions here. So if we know an angle on one side of a right triangle, we can always find the other side using a trig function. So what we need to do is determine which one we need to use. So if we use 25 degrees as our reference angle, and we could easily figure out angle A right here as well and use angle A, it wouldn't really matter, but let's just use 25 degrees because that's what's given to us. So in reference to angle A, the side we know is 5, so we're definitely going to use this side because we know what it is. And of course that is the adjacent side. Okay, so then the side that we're trying to find is AC, so which side would that be? Well, because it is opposite, or 25 degrees, that is what we call our opposite side. Alright, so whenever you're doing trig, you can always write this down. Why did it do that? Our little mnemonic device. You don't have to do this, but you can, of course, if you need to help you remember what they are. So we want to use the adjacent and the opposite. So looking at our three options here, the ones that uses adjacent and opposite would be right here. So we're going to be using tangent. Okay. So it is important that you pick the right function. If you try to use one of the other twos, you would have the hypotenuse involved, and we don't know anything about the hypotenuse. So we wouldn't be able to figure it out. Okay, so we want to know everything except for the opposite. And because we know the adjacent side and we know our angle, we can use tangent to find the part that we're missing. So tangent is opposite over hypotenuse. So tangent, and whenever we do the trigonometric functions, the base trigonometric functions, it's always a function of an angle. So we're taking the tangent of 25 degrees, and we know that is opposite over adjacent. Alright, so what we can do, because we know what our adjacent side is, we can fill that in. So for opposite side, I'm going to put in an X. You also could just use, you could just write it like this, AC. That represents the length, that represents an unknown quantity. But you can always just use an X too if you're more comfortable just using that. And then our adjacent side is 5. Okay, so the question is, we want to get X by itself here because we want to figure out what it is. So the right side is where the X is, so we're dividing by 5. So algebraic processes, we're going to do the opposite of dividing by 5. We're going to multiply by 5, which means we're going to do it on both sides. So here we have 5 divided by 5, so these cancel out. So what I'm left with is 5 tangent 25 degrees is equal to X. If I flip this around, I will have X equals 5 tangent 25 degrees. Okay. So sometimes, depending on what's being asked, this would be what we would call an exact answer. It could be acceptable in different situations as your actual answer. I'm going to go back to Khan Academy, and I'm pretty sure we're going to have to come up with an approximate answer. And so we'll have to use a calculator to do it. So scientific calculators will always have the trigonometric functions built in. Okay, so our answer is going to be 5 tangent 25 degrees. Okay. And so it says round your answer to the nearest hundredth. So this is asking for an approximation. So what we can do is use our calculator. Notice my trig functions here. So let's try it like this. 5 times tangent 25. And you can actually drag your calculator around. That's kind of interesting. And one thing I want to mention, when you use calculators, you always want to make sure it's in degree mode. Okay, this is we might get to this later on, but there's actually another way to talk about angle measure. It's called radians. Don't need to worry about what that is right now. For right now, we're just doing degrees. But whenever you're putting an angle in degrees, you always want to make sure you're in degree mode, or it's going to calculate it incorrectly. So we hit equals, and so we get approximately 2.331. So if we round to the hundredths place, it's going to be 2.33. So let's check our answer. And cool, we got it correct. So that's just a brief review of how you can use trigonometric functions to find a missing side. Okay, so from here, what I'm going to do is I'm going to go to now we want to find an angle. Okay, so this is a practice set that you guys are going to be doing today. And I'm just going to pull up an example problem. I don't know what problem it's going to give me. Alright, so here we are given a right triangle. We know 2 of the sides, and we're asked to find an angle now. Okay, so I'm going to go over to my whiteboard and make sure you guys can actually see it. And let's copy the problem. So we have triangle ABC. A, B, C. This is where I really need to have a second monitor so I can look at both really quickly. So we know AC is 2 and AB is 3. And we want to find what is the measure of angle B right there. Alright. Okay, so before I dig into this, I want to talk a little bit about the trigonometric functions and also talk about inverse functions a little bit. Okay, so looking at this angle, if this is our reference angle, we don't know what it is, but this is going to be our hypotenuse, and this is going to be the opposite side. Oops. Sorry, it's hard. The handwriting still isn't great. So if we call this theta, let's just call it theta to represent whatever this angle is. Because we're doing opposite and hypotenuse, that's going to be my sine. Okay, opposite. Sine is opposite over hypotenuse. So in other words, sine of theta is going to be equal to opposite over hypotenuse, so that's going to be 2 over 3. Okay. So the sine function doesn't necessarily help you here a whole lot because you don't know what the angle is. You need some way to put in the ratio to find the angle. Normally when you're plugging a trig function in your calculator, at least what we've been doing so far, you will always know the angle. and then you're finding one of the sides. Now we know two of the sides, we need to find the angle. Okay, so recall what I've been saying before, that when you do the sine, you're always going to take your angle as an input. So if you think for a second about functions, so sine function, thanks for messing up my F. Or any of the trig functions, it could be cosine or tangent or whatever, but it takes an angle as an input, and then you put it into the function, and then it gives you a ratio, a specific ratio of the two sides depending on what your function is. For sine, that would be opposite over hypotenuse, or the ratio of the opposite side divided by the hypotenuse side. Okay, so what we want to do, we know the ratio. We want to go back to finding the angle. So how can we do that? I encourage you to stop and think about this for a second. So in algebra, I always say algebra 1, you guys have integrated math here, but you should have talked about what an inverse function is. The idea of an inverse function is just that whatever it's, So if you have a function, you have an input and an output. So the inverse of that same function, what it should do is it should take the output, and then it should send it back to whatever your original input is. So what we need is an inverse sine function. Okay, and so that's exactly what we're going to use, and that's exactly what it's called. So we have the inverse sine function. That's what we're going to use. So the inverse sine functions take the ratios and give you the angles. So the way we write these out is a little bit different. We write the ratio, and then we write it like as an exponent. We write a little -1 up here. Okay, and so remember, because an inverse sine needs to take a ratio as its input. So the way we would write this particular one is we are writing inverse sine of 2/3 equals theta. So that means that the input of an inverse trig function is a ratio. The output is going to be an angle. Okay, and so we also have inverse of cosine, and let's just use general letters here. It's going to take a ratio as an input, and it's going to have the angle as the output. And same thing with tangent. Inverse tangent, it's going to take a ratio, and once you take the inverse tangent, it's going to tell you what that angle is. Okay, and so this is again something that a function that you will do on your calculator. If you search, you can also find tables of values for various angles and ratios and things. And of course, back in the old days, before calculators were invented, that's what everyone had to use. They had to use these tables. But nowadays we have calculators we can use, and so we'll be using a calculator to calculate this. All right. So this is just the basic idea of what an inverse sine function is, or all of the inverse trig functions. So again, our basic trig functions, sine, cosine, and tangent, they all take an angle as its input, and then they give you a specific ratio. For the inverse functions, it works the opposite because it's the inverse. So it's going to take the ratio as its input, and then the output will be the angle. Okay, so it's just the reverse, just the inverse of your regular trig functions. Now, a couple quick things. I generally don't write it like this, but sometimes you will see it written a little differently. Sometimes you will see it written as arc sine, or arc cosine, or even arc tangent. This is the same exact thing. It's just a different way of writing it. Another thing people can get confused by is because this is inverse sine, inverse cosine, inverse tangent. This is not a negative exponent. Okay, it is a completely different thing, even though we use the same notation, if you will. If I really want to write and like this is to the -1 power, the way I would write it would be like this: sine of 2/3 to the -1. Okay, that is how you would write it. If you write the exponent on the sine function itself, now that's an inverse sine function. That's two different things. Because remember, if you were to write this as an exponent, it's the same as 1 over sine of 2/3. Okay, so be careful with that. It can be a little confusing when you're first getting used to it. All right, so I talked a lot about kind of the ideas behind this, so let's go back to our original problem here. So it's actually not going to be too much work. It's mostly going to be the calculator doing the work. But so basically we said that the sine of this angle is equal to 2/3. So the way we're going to do this is we're going to use the inverse sine. Because I know the sine is equal to 2/3, if I take the inverse sine of 2/3, that should give me the angle theta that I want. And so basically all you're going to do is plug this into your calculator here, and that should give you your answer. So we need to do inverse sine of 2/3. So let's go now back to our Khan Academy practice. Okay, looks good. And again, it says you might need a calculator. Yes, we are going to need a calculator. And so notice on your calculator you have sine, cosine, and tangent. Right above it you have, the inverse trig. Sine to the -1, cosine to the -1, and tangent to the -1. So we are doing sine to the -1, or I shouldn't say that, sine to the it looks like sine to the -1, but it's really called inverse sine. Okay, and then it says a sine, which I'm pretty sure is just shorthand for saying arc sine. But we need to do 2 divided by 3 in parentheses equals, and now remember this is our angle. Okay, this is our angle measure, so we need to round this to the nearest 100th, which is 2 decimal places, so there should be 41.81. So let's check our answer here. And looks like we got it correct. Okay, so there's a basic overall idea of inverse sine functions. So whenever you are finding your angle, you will need to use the inverse sine or the inverse tangent or the inverse cosine. All right, so thanks you for joining me, and have a great day, guys.